Okay, welcome again to our session, statistics and data analysis. This is the week 9 of our computer application subject. This is the elective program, and no, the Lucia, you, it doesn't make you record this. I will give the recording to your group, and then you can watch from there. I'll attach it to the Google Drive so that you can download the recording from there. So this objective for today is to understand, the objective for today is to understand the type of statistics in research, differentiate qualitative and quantitative data, identify the suitable frequency distribution for data analysis, create appropriate graphical representation for analysis report. So why do we study statistics? Because we're dealing with numbers. Data is everywhere, and data numbers are very concrete and absolute. They say that math is the absolute science. Mathematics can give absolute data interpretation. Statistical techniques are used to make many decisions that affects our lives. So that's why we study statistics. And no matter what your career, you will make professional decisions that involve data. So if you're going to do qualitative study, qualitative will not have all these statistics, but it's nice to know because it will involve your professional decision making as you involve with data. An understanding of statistical methods will help you make these decisions effectively. So the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions is what you call statistics. So statistical analysis is defined as is used to manipulate, summarize, and investigate data so that useful decision-making information results. Statistics, this is the statistics, okay? It observes, it asks questions, and then it make guesses or hypotheses, tests and measure and draw conclusions. And then it set thresholds, it analyzes data, it interprets results. This is the flow of the statistical analysis. So the quantitative research is more likely the one that will benefit on statistics because the objective facts and numbers will be statistically analyzed, and quantitative is more numerical. So measurable fixed reality is quantitative research, and data collected through measurement and reported in statistical terms are the statistical quantitative research method. So qualitative research can also have numbers. Why not? Non-numerical information is qualitative, but it can have a rich description of the numbers that they have, such as how many men, how many female, such as how many said yes, how many said no. Simple describing of numbers is enough, but it's still descriptive though. So you're still describing it qualitatively. You're using numbers to describe things qualitatively. Dynamic and negotiable in reality, data collected through observation and reported as quotes. Quotes like interview. So the in-depth interview will have quotes. That is qualitative research. The difference between the two is very easy. The qualitative uses the why and the open-ended questions, while the quantitative is more of the variables that has numerical interpretations and symbols of numerics. If you mix it, then it becomes a mixed approach. So you combine quantitative and qualitative, you fuse them together, and you're gonna have a triangle. So you have a mixed methods. Types of statistics. The descriptive statistics are methods of organizing, summarizing, and presenting data in an informative way. Inferential statistics is the method to determine something about the population on the basis of a sample. Inference is diagnosis. So when you say describe, you're just organizing, summarizing, and presenting data in an informative way. How many said blue? How many said red? How many said green? How many said yellow? How many said pink? How many said purple? Those are describing the numbers of what you have acquired as a data is descriptive. Inferential is diagnosing. What is your diagnosis of having many blue, less than red, and the yellow is the last? What's your diagnosis? Okay, the diagnosis is blue is the favorite color, okay, or red is the second favorite color, yellow is the least favorite color. Okay, so the spectrum of those primary colors, the spectrum is more complex. Magenta, purple, indigo, those are the spectrums, are combinations of all those primary colors. They can have an inference as well. This method's used to determine something about population on the basis of a sample. For example, the population, the entire set of individuals or objects of interest, or the measurements obtained from an individuals or objects of interest, which means to say you're trying to make a diagnosis of the entire interests of a population. Or a sample, if it's only a sample, then a portion or part of the population of interest. Diagnosing only a portion or a part of the population of interest, that's what you call inferential statistics. Inference means diagnose. Okay, so this is the population. The population here, here. The population here is bigger than the sample. Always remember that. The biggest entire population can still have a small sample size, which is recommended for you. Because you don't want to get the entire country's population, you can choose one small portion of that, and that will be the selected item from the population that will be inside your data analysis for your research. So inferential statistics estimates the population mean weight using the sample mean weight. They're trying to get they're trying to take some inclusion and exclusion criteria. Hypothesis testing is to test the claim that the population mean weight is 70 kilogram. So that is what you call the test for hypothesis. Inference is the process of drawing conclusion or making decisions about population based on sample results. Trying to diagnose, draw conclusion, and then make decisions about population. That's what you call inference. So the sampling, a sample should have the same characteristics as the population it represents. So it is unlikely, it is still possible. It is still possible that a sample does not represent the entire population. Maybe those samples you took are the exclusions of what it represents from the entire population. But that will have a lot of biases. So be careful with choosing your sample. It has to represent the total population that you're trying to take, because you don't want any biases to come about on your research when you choose or represent a sample that does not represent the total population itself, which can happen, rarely happen. If you want that to happen, that means your research would like to have a defeated hypothesis. You would like to you would like to fail on the hypothesis that you have. That's why you do not want the population to represent the sample itself. With replacement, that means sampling can be with replacement or without replacement. A sampling with replacement is a member of the population that may be chosen more than once, picking the candy from the bowl. Like a fishbowl, the fishbowl technique of sampling. You put all the populations there with replacements, then you choose, in a fishbowl technique, picking up the bowl, and in the fishbowl technique, you will only choose randomly what is inside your general population. So that will be a non-biased way to take your sample size. Without replacement, is a member of the population may be chosen only once in the lottery tickets. That means once you are chosen, you're no longer belonging to the bigger population, but on the sample size that you would like to have. So sampling techniques, sampling methods can be random and non-random. That's the two biggest one. It can be random and non-random. That's a sampling technique, the bigger description of a sampling technique. Each member of the population has an equal chance of being selected for the random. That means all members will be selected for sure. For the non-random, the actual process of sampling causes sampling errors. For example, the sample may not be large enough or representative of the population. That's what I'm saying. The non-random can happen because some of the samples may not be representative of the population. You can have that. It depends on your purpose, it depends on the purpose of your study. If your purpose is to fail the hypothesis, then you do the non-random, which does not represent the population itself. Yes, it can happen. Factors not related to the sampling process cause non-sampling errors, and a defective counting device can cause a non-sampling error. Therefore, it's leading to a bias that you want to defeat the purpose of the research. Random sampling methods. The simple random is each sample of the sample size has an equal chance of being selected. That's simple, as that. Stratified, they have divisions of the population into groups. They call strata, strata 1, strata 2, strata 3, or group 1, group 2, group 3, or cohort 1, cohort 2, cohort 3, or division 1, division 2, division 3. So those strata take a sample from each stratum. Those strata, you have to pick samples from this division, sample from that division, sample from this division, and combine them, and then you have a sample of the divisions that you have stratified. The cluster sampling is dividing it into clusters, like for example, age group, gender group, male, gender group, female, age group young, age group middle age group old age, the adolescent, adult, late adult, and the geriatrics. Okay, those are the clusters. You cluster them all together. All members of the same strata are in cluster samples. It's not just the divisions, but in the strata, you cluster them further. So systematic sampling is a random select a start point and take every nth piece of the data. For example, every third of this population I will choose. Every third, or every second week of vaccine, So these are the number of populations who had vaccinated with COVID-19, and then only the second week I will choose, 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 second dose, sorry, not second dose. Second dose, sorry. The second dose, I will choose second dose, bring them all together, expose them to COVID-19, and test whether they die or they live. So those are the nth piece of data from a listing of a population. That's what you call systematic sampling. Descriptive statistics is collecting data or survey. Usually, we are very, very comfortable with surveys because this is very descriptive and this is the easiest thing that you can do. So the survey is just collecting the survey. How many loves candies? How many loves chocolate? How many loves bubble gum? Those are descriptive. How many? Raise your hand. So those are descriptive. The present data example, the tables and the graphs, are also descriptive. They're describing you in a whole graph. There's a pie 100%, and how many percent do you want to divide the 100? That's the pie graph. And summarized data example are the mean. The mean is the center, the average summation of x1 to the nth x. Add them together, divided by how many are they. That is the mean, or that is the average. And the mean is the center, okay? The average is the center. What is the center of your whole data that you have been describing? So, statistical data is the collection of data that are relevant to the problem being studied and is commonly the most difficult or expensive and time-consuming part of the entire research project. So, let's say you are a qualitative researcher and you don't have so much statistical data. The time consuming that you have is to transcribe your written or your verbal interviews, or your observation is to transcribe the observation. That is the most difficult part for a qualitative. But for a quantitative researcher, the most difficult part is the statistical data because it's time consuming, and part of the entire research project uses a lot of primary data and secondary data collection. Statistical data are usually obtained by counting, measuring items. So what is a primary data collection? The primary is you yourself collected the data. Primary data collection are collected specifically for the analysis desired. That means you, as the researcher, collecting the data itself. If it is an experiment, you're the one who did the experiment. So what is a secondary data collection? It has already been compiled for you and are already available for statistical analysis. For example, you do not know how to read COVID-19 blood extraction. So you have to do a secondary data collection. Bring it to the laboratory, they will give it to you. All the results will be found on the laboratory, and then you have to collect it. Let's go for business. Maybe you're not into science, you're into business. If it's a secondary data collection, all you have to do is go to the income tax. Maybe you're looking at the taxation evasions or any taxation anomalies or cheating within the government, those kinds of business things. You have to go to that institution which they have already collected for you, and what you need to do is get all those data, and that's your secondary data collection. And you only have to do is get your own checklists, tabulate it on your own. That's your tool, and you're not the one who collected the data. You're not the one who collected the taxes, or you're not the one who collected the all the blood chemistries and all the blood results. It's only a secondary data collection. You got it from something else, not you who did the experiment, but somebody else who has done it for you. And all you have to do is compile it and analyze it for further research. This is also what's happening in CPR, because usually the compression only CPR versus ventilation with compression CPR, they don't do the experiment itself. They cannot be there. The rescuers are the rescuers, and the researchers are the researchers. So the researchers are doing secondary data. What they have collected retrospectively from before are being analyzed to the present. Therefore, they're just trying to analyze it as a secondary data source. So try to think about your data collection. Are you the one who's going to do the experiment? Or are you the one who's going to do this? Or somebody else has done it for you, and all you have to do is collect it. Like, for example, in education, maybe you want to know the grades of the students. You were not the one who taught them. You never gave them the grades. You just went to the university and collected all the grades of the students. That is what you call a secondary data collection. You take from what is already compiled and already available for statistical analysis. You're not the one who took it. Somebody else who has done it. So be very concrete with your data collection. Are you the primary data collector, or are you the secondary data collector? A variable is an item of interest that can take on many different numerical values, and a constant has a fixed numerical value. So those are the terminologies that you need to remember. Data. So the data can be quali and quanti. We know this. We already know this. The quali is something that is not measured by numbers, such as the hair color, ethnic groups, and other attributes of the population. Maybe the attitude, those are the qualitative data that is very difficult to measure, because you need variables to measure it that are concrete. Quantitative data are observations that are measured on numerical scale, like the travel, kilometers per hour. Okay, that's the travel. Or how many miles, number of children, how many, 1, 2, 3, 4, 5. How many, how much? Those are quantitative data. So qualitative data are generally described by words or letters. They are not widely used as quantitative data because many numerical techniques do not apply to the qualitative data. For example, it does not make sense to find an average color or blood type. So those are the qualitative data. So the qualitative data can be separated into two subgroups. Dichotomic, if it takes the form of word with two options such as gender, male or female. Or polynomic, if it takes the form of word with more than two options such as education, primary, secondary school, and universities. Okay, so let me share to you what qualitative is. Qualitative is generally described by words to be a lived experience, okay? It can be any living thing. It can be any living organism. Not just the word that they see on the business thing that they put on analysis of words and it's qualitative. No, it can be a secondary data collection, but it is not a qualitative research. So that is not considered as a qualitative research. Okay? You cannot use qualitative data by just typing down words of something that is infrastructured or tax evasion thing that you want to describe in words, not in numbers. You better describe it in numbers because it is not going to be a qualitative. So that is the qualitative data that you should be careful with. Be careful with this qualitative terminology. Quantitative data are always numbers and are the results of counting or measuring attributes of a population. So quantitative data can be separated into two subgroups, discrete and continuous. What is a discrete? Discrete if it is the result of counting the number of students of a given ethnic group in a class, the number of books of a given shelf. We know what discrete is. You know, we have all these discrete and continuous. So continuous is measuring continuously, like the distance traveled, the weight of the luggage. Those are the continuous. Discrete is something that it's quite difficult to count, but they are still in numeric. So how many are the discrete? Remember, the variables is divided into two, quali and quanti. So the quanti and the quali, the dichotomic and the polynomic for the quali, and the discrete and the continuous for the quanti. So gender, marital status, as you can see, brand of hair, color, those are the polynomics. And the discrete is children and families, strokes on the golf hole. Okay, so those are the discrete and continuous. Numerical scale of measurement. So the nominal and the ordinal is the numerical scale of measurement. The nominal consists of categories in each of which the number of respective observations are recorded, and categories are in no logical order and have no particular relationship. The categories are said to be the mutually exclusive, since an individual or object are measurement and can be included in only one of them. So that's what you call the nominal. The nominal is in the number of respective observation, while the ordinal is the order of, like good, fair, poor, or we always use the strongly agree, disagree, neutral. Those are the order, in the order of, like the highest to the lowest, tallest, medium, shortest, or order of age, old, young, children. So those are in the order of the ordinal. Fair or poor, those are the order of good, fair, and poor. Interval is a set of numerical measurements in which the distance between number is known and constant in size. So there's in an interval, every how many intervals you want. There's an interval here, there's an here. Ratio is 1:2. There's a numeric measurement where the distance between numbers of a known constant size, in addition, is non-arbitrary to 0 point. So there is a non-arbitrary to 0 point. 1 is to how many? 2 is to how many? That is a ratio. Or proportion. You can call it a ratio and proportion. So, numerical presentation of qualitative data, they have pivot table, or qualitative dichotomy statistical attribute, contingency table, qualitative statistical attribute, from which at least one of them is polynomic, and scholars should know how to convert absolute values to relative ones. So, steps for constructing frequency distribution. This is the frequency. You know how many frequencies you have. The frequency is the number of samples that you have. Determine the number of classes. Determine the size of each class. Determine the starting point for the class. And tally the number of values that occur in each class. And prepare a table of the distribution using actual counts and or percentages, relative frequencies. So the frequency table have absolute frequencies such as data tab to data analysis and histogram. So relative frequency is F1, is shown as F1, and absolute frequency is shown as NI or N1. So cumulative frequency distribution shows the total of number of occurrences that lie above or below certain key values are cumulative. That means you have to combine them all together in a cumulative way. Cumulative frequency is NI or N1, or cumulative relative frequency is F1. Chart and graphs frequency distribution are good ways to present the essential aspects of data collection in concise and understandable forms. The pictures are always more effective in displaying large data collections. So if you have graph, it is more it has more thoughts and more words to speak rather than writing it down, because the graph will show you the display of data collection. For example, this is a histogram. As you can see, the histogram is used to graphically present interval and ratio. There's a there is a bell curve that you can see from a histogram, and it's often used for interval and ratio. The adjacent bars indicate that a number or numerical range is being summarized by indicating the frequency of arbitrarily chosen. So how many will go higher and how many goes lower? That is showing the frequency of arbitrarily chosen classes. Well, the polygon, another common method called the polygon, they're graphically representing interval and ratio. So to construct a frequency polygon, mark the frequencies on the vertical axis. So the vertical axis, you mark the frequency, and the values of the variable being measured on the horizontal axis as with the histogram. If the purpose of presenting is comparison with other distributions, the frequency polygon provides a good summary of the data. A graph of cumulative frequency distribution, the OGIV, they are used when one wants to determine how many observation lies below at this peak, going all the way up. That's an OGIV. First, cumulative frequency distribution is constructed, and then cumulative frequency are plotted at the upper class limit of each category. So OGIV can also be constructed for relative frequency distribution. Okay, the pie chart is 100%. So anything that is 100%, you go to a pie, and then you divide it into a few percentage, and then you will see the distribution of the 100%. So this is one of the misconceptions of pie graph. Sometimes they put pie graph into 120%. They're not counting the percentage sometimes. Sometimes it's all over 100% already. So don't go beyond 100% of pie graph. Sometimes they put 50, 50, and 50. 50%, 50%, 50%, 50%. That's 200. That's not a pie graph anymore. Better use a histogram or a table. So don't be misconceptualized by a pie graph. It has to be 100%. 40 plus 10, 50. 20 plus 30 is 50. 50 plus 50 is 100. So don't be too engrossed with pie graph. Then in the end, you will have 300%. You know, you never calculated, you never counted. So a pie graph must always be 100%. So if you don't want the 100% pie graph, there's a lot of 50% there. Then use this bar chart. Okay, so you use a bar chart. Another common method of graphically representing nominal and ordinal scales is the bar chart. You know, everyone is 50%. Everybody is 90%. 90% of this, 90% of that, 90% of everything. So you cannot put that on a pie. Okay, there's no such thing as 90% of everything in a pie. So a pie has to have 100. You have to divide it into 2 or 3 or 4 or 5 until you get 100% equally distributed. Now, if you have more than 100%, you can use a bar graph, and it separates. You see, the bar graph must be separated by colors, and also you don't confuse the viewers, because some colors can be a little bit similar to each other. If you think that this red is similar to that red, then don't combine the two reds together. It might look like it's the same, okay? You put something different color in between them to separate them in a spectrum. You know, the color spectrum must be separated so people will not get confused on the bar graph. This is what you call a series graph. So a series is measured over time. If you're doing like 6 months, or you're doing a revenue of December to January revenue during COVID-19, better show them the time series graph, okay? Or for example, you made an experiment on diet and exercise within over a few months, sometimes years, 1 year, 2 year, okay, a few months, 6 months. So you put them a time series graph so they can see the fluctuation between the control variable and the fluctuation of the experimental variable. So there are fluctuations of the control and the experiment. And if you're doing money, this is the best way to show. The time series graph is the best way to show fluctuations of money, because you will find how the horizontal axis of the graph represents each period of axis, where numerical corresponds to time periods. Is this time better revenue, or that time is a poor revenue? As you can see, the revenue here is falling down, blue, and then the revenue there is high, okay? Maybe this is the 2019 revenue, and then suddenly 2020 January revenue fell down. because of the COVID-19. So those are fluctuations. Time series are always fluctuations. So those are the graphic analysis of qualitative and quantitative. Now, can a qualitative have graph? Of course. It doesn't mean that it is qualitative, it doesn't have to have a graph. You can. You can distribute the male and the female, as simple as that. Simple graph analysis. For pie graph, you can do so. Or you can put a graphic analysis of the bar chart of their answers. These are the answers of preference of parental consent for orphanage, for getting some orphans. These are the bar graph that shows them that these are the experiences of the parents. You can do so. You can do any graphic analysis for qualitative study. But remember that it is not numerically analyzed in the end. It is still qualitatively analyzed. So visuals makes it colorful. Visuals makes it attractive, interesting, especially when you are trying to publish articles. The visuals are very attractive to readers. So go to Google. Okay, you have to um, okay, this is the Google. Okay, you have to go through your Google, and then you have to sign in. Hold on, my Google is hanging. Okay, you have to sign in here. This is me. I've already signed in. Okay, this is my username and password. Alright, you have to sign into the Google, and you have to type down docs.google.com/forms. Okay, did you remember that? docs.google.com/forms. Don't worry, this is recorded. Are you with me, Oyele?
Yes, I'm with you.
Alright, so this is the blank document for docs.google.com/forms. You have to click this blank, not the quiz, but the blank document.
Okay.
Okay, so you have to put here the title called Influences of Occupational Stress, blah, blah, blah. I don't want to remember your title. You're the one supposed to remember that. And describe those who are going to be answering your survey questionnaire. How do you find who are going to answer the survey questionnaire? These are the inclusion and exclusion criteria. Now, let's go to your proposal again and let's read your inclusion and exclusion criteria on your chapter 3. Can you see the screen? Oyele, are you there?
Yes, I'm there. I'm seeing the screen.
Where are your inclusion and exclusion criteria? Okay, this is the only exclusion. Okay, you can copy this, copy, and then go to your Google survey form. Okay, then paste it here. This is your statement. So this study will include all nurses present at the time of data collection. So can we go to your consent form from your survey questionnaire? Now let's go to your survey questionnaire. Okay, the bearer is a postgraduate study. You can copy this as well. All right, copy this and you can put it there. Oh, you can copy until yours truly, yours faithfully, Oyele. Okay. And then go to your Google survey form. All right, and then put here at the beginning. Okay, so Oyele, and then the study will. Okay, you can put here the study will include. All right, so this is your letter. Okay, the letter that you have for them. Okay, this is the bearer, blah 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 blah. You can just revise it, but as long as their inclusion and exclusion criteria is here, will include all nurses present at the time of data collection. This is very vague. You mean, what do you mean by that? Your inclusion and exclusion criteria is so confusing. If I am the one who will answer your survey questionnaire, what do you mean by this? Am I gonna answer this survey questionnaire? I don't even understand what your inclusion is. Can you make it clear? If you are a nurse working in Federal Medical Center, Asaba, and you are working there more than 1 year, and not on leave,
Okay.
vacation leave. Can you make it clear? So when I answer your survey questionnaire, I don't want to throw away your survey questionnaire because I confuse. Am I part of this? Who am I here? I don't even understand what you want. So make it clear on your inclusion and exclusion criteria who are going to answer your survey questionnaire from your chapter 3 methodology section. All right, now when you try to write, all everything here is clear and complete on your writing of your introductory, you go to this setting. This is the setting. Okay, the setting, you click the setting. This is not a quiz. It's not a quiz. You click the response. All right, you click the response and you have to collect their emails. So they have no choice but to give their email to you. Send responders a copy of, they don't need a copy. Allow response editing. Allow them. Okay, click allowed. So it's blue. They can edit their response. Require signing in, limit to one response. Don't limit to one response, or maybe you can limit to one response. It's up to you. Maybe they can limit it to one response, so it will not be biased. They can do over and over again. No, it will not be biased. You can limit it to one response. Show progress bar. You don't need to show progress bar. You don't need to shuffle the question in order. And after submission, you can edit this. You can confirm their responses. Say thank you. Thank you. Don't forget to say thank you to them and then save. And then show link to submit to other response. Disable limit to one response. You have to disable this limit. They can show link and submit another response. So view result. You don't need to view result. They don't need to see the results. Disable autosave. Do not disable autosave. They have to autosave. So when they want to go to toilet and they want to poo poo pee pee or take a shower for a while, they can come back and it will autosave for them. So don't disable the autosave. So the next thing is, you have to collect email address and everything has to be default. Make question as required by default. They cannot go to the next section until they finish all the questionnaires at at that at that section. So let's go back to the next section. This is section 1. Okay, this is what you call a section, and this is what you call a questionnaire. So this is the section and this is the questionnaire. Now, if I click this add question, it will add more question. If I click this section, it will add more section. So I don't want to click more questions because this is just an introduction. So all I have to do is make a consent. I agree to the terms and conditions, and I allow my answers to be published for academic purposes. I also am aware that my privacy will be respected. My information will remain anonymous and confidential. I am also aware that I can withdraw my answers to this survey anytime I deem it necessary. So this is the consent, okay? There's no other option but yes. Don't put a no, okay? And make sure it is a multiple choice questions. Do not use short answer. Do not use paragraph. Don't be lazy. You put paragraph because you don't want to put all your questions there. No. Only multiple choice questions because SPSS cannot read paragraphs and essays. So there's only one option for them, which is yes. Don't put no because they have no other choice but to say yes. If they don't say yes, they cannot go to the next section. Therefore, they will not proceed to the next one. So what do you do next? You don't click the add questions, but what you do is click the add section so that when you click the add section here, let's preview. This is what you call the preview icon. This eyeball that you're looking at is what you call a preview icon. You can click this preview and it will show you. You see, it will show you. You cannot go to the next section until you agree, and there's no such thing as no. Okay, they cannot disagree, they can only agree. If they don't agree, then stop the survey. You don't have to continue with the survey. So this is your questionnaire, and they will put their email and they will click yes. Okay, they put their email there. Okay, that's their email, and they'll click yes, this is a required, before they can go to the next section. Otherwise, forget it. Don't answer this survey questionnaire and this topic, and we do not need you anymore because they did not agree. They don't agree. They don't agree to be published. Okay, there is no no, only yes. Everybody, can you hear me on the consent?
Yes.
Yes.
Okay.
Yes.
Clear?
Yes.
All right. Next, the next one is for you to put your first section. First section, you need to put social demographic because Oyele wants to have social demographic. So first, the section A will be the social demographic. It's called a social demographic data. That's what his first questionnaire is all about. So I have to go to the survey questionnaire and I have to copy one by one the social demographic data. Okay, this is the marital status, single, married, on divorce. Okay, I'll copy that and I'm going to my survey questionnaire and I'm gonna paste it here. Paste. Okay, I'm gonna copy this, cut. Okay, cut this out and then click this option and paste here. Alright, and then cut this out, click this option and paste here. Okay, then delete this optional thing and then copy this, cut, put another option and paste, and then delete this and then
You are not going to again.
hello, are you there? Hello.
Yes.
Yes, we are here. We continue. Continue. So please move on.
Okay, so now this is marital status, and I'm gonna click this plus button again, and then I'm gonna have another question. Hello, Oyele, are you there? Oyele.
Yes, I'm here. I'm here. I'm here.
All right, where am I?
Second question.
You are talking about the marital status.
So what's the next second question? Hello, what's the next second question?
The religion. The religion.
Okay, religion. All right, we go to the religion and we put here on your Google survey form and we paste here, remove this Christian and cut it and put it in option 1. Not short answer, but multiple choice. Remember, multiple choice, not short answer. And then cut this off and then put it on the next option and then paste this and then remove this. Close and open parenthesis and then paste it here and then remove this close and open parentheses.
Oh, no.
That's it. That's your traditional Islam and Christian. What kind of religion is traditional? I've never heard this religion ever again in my whole life. What kind of religion is traditional? Can you explain to me?
That is those who are neither Christian or Muslims.
A Satanist.
Those who are neither Christian or Muslim. They practice
So what do they
traditional
worship?
religion. They worship
They worship
juju,
idol.
idol.
Oh, like a pagan.
Yes.
Yeah.
Exactly.
Okay, so you call it
They
traditional.
worship idol.
Okay, no problem.
Yes.
Then we go to the next one. What's the next one?
Age.
Age. All right, we go to the next one, age. So we put age here. Paste. We just copied it and then cut this off and then put this on the option. Remember, not short answer. It will automatically give you a short answer, but return back to the multiple choice. And then these are the brackets of your multiple choice. Cut
Hey,
the
sorry. Hey,
what?
sorry.
What is that? Okay.
Please continue.
Okay. I'm continuing.
Please go ahead. Sorry about that. Go ahead.
It's done. The next one is what's the next one?
Educational background.
Attainment. Educational attainment.
Educational attainment. Yes.
All
Okay,
right.
yes.
Got this. Then put the option 1, paste. Multiple choice, huh? Remember, it will automatically give you an essay, but return back to multiple choice questions. Okay, then remove this nursing degree. And then next, you have to click the plus sign, not the section, but the plus sign. Okay, plus sign. Then we go to the next one. The last is the rank.
Hello, sir.
No. Yes.
Sir, please, with the age 15, 15 is not a minor. Is he allowed to answer research questions? I mean the age 15
No, it's not allowed. Yes, you're correct. It's supposed to be 19.
or even 18.
Can you be a nurse when you're 19 years old and 18? I think this is
It will be
remove this.
impossible here.
You start with 26 years old. Can you be a nurse at 21 years old?
Yes, that
please.
one is possible.
Yes, it's possible.
Oh, then you start with 21. Remove that 15. You, Oyele, you don't put something that is questionable there. Okay, so remove that 15 and then start with 21 years old. So now we're going to the rank.
Even 20 can finish nothing before 20.
Okay, fine. You put here 20 to 35. Okay, start with 20 to 35. So we're now at the rank. CNO, remove this the open and close parenthesis, cut, and then paste this. Use your mouse. You have a mouse? It's faster if you have a mouse. Look at me. It's so fast because I have a mouse. But if you're gonna use your fingers to scroll on something that is found on your laptop, then it will cause you a lot of problems.
Sir, please, what is AND, the rank? Like
I don't know what that
It
is.
should be ADN, Assistant Director of Nursing Services.
Hi.
ADN,
Assistant.
Director of Nursing
8 years.
Services.
8 years. Don't put 8 years.
Never mind. What is CNO?
Chief Nursing Officer.
Okay.
Chief Nursing Officer,
Yes. What is PNO?
Principal Nursing Officer.
Principal Nursing Officer,
Okay. What is SNO?
Senior Nursing Officer.
Senior Nursing Officer,
All right. Nursing Officer 1. Nursing Officer 2.
Yes.
All
Yes.
right. These are the staff nurses, right?
Yes.
yes, please.
Okay. That's the end of our demography, isn't it? That's the end of the section demography, right? hello. Oyele.
Yes, sir.
Okay, then after that demography, we click on this icon called section because we're done with adding questions on the demography. We're now going to add section 1, which is the influence number 1, called, what do you call that? Influence number 1 again? Sources of occupational stress. Okay, this is now the influence number 1 called sources of occupational stress among nurses. Okay, that is what you call the influence 1 because your title is influences, isn't it? So this section is called sources of occupational stress among nurses. Okay, then you click this button again called add questions, not add section but add questions, and then you put here okay, you put here the sources. Okay, sources of occupational stress. Or maybe you can change this. You change this into another section called influence number 1. Okay? You can make this a section influence number 1. All right? So
Okay.
your influence number 1 will be sources of occupational stress. Now, you cannot make multiple choice question here because you put a multiple choice grid. So you put a grid here. The columns here will be on top and the rows will be at the bottom going down. The horizontal and the vertical row. Okay, so this will be a multiple choice grid. Don't put multiple check boxes because you cannot check boxes at the same time together with the row. So all you have to do is click multiple choice grid. So all your columns will be the SA, A, and the D. SD. Okay, strongly agree, disagree, and strongly disagree, right? Are you with me?
Yes. Yes.
Everybody with me? This is the column. Column going down. The vertical axis. Okay? We put the multiple choice grid because this is a grid. Right? This is what he did. So, we're going to follow what he did. We're going to put multiple choice grid. Alright? We're going to go here. And then the column here, we're going to paste it there. Can we just put here strongly agree? And then agree. And then disagree. And then strongly disagree. Okay, so these are your columns, the one that's going up. So the rows will be copied paste as well. We're going to go back here and we're going to copy all the rows. Copy. Paste, and then next is copy. Paste, and then next is copy. And then paste here. Okay, and then next is copy, and then paste here, and then next is copy, and then paste here, and then next is Copy. And then paste here. And then next is copy. And then paste here. So tell me, is it difficult? Let's see how it looks like. Alright, this is how we do it. Let's try to agree. Click next. Okay, this is I'm single, I'm a Christian, I'm 36 to 45. You see, I can only choose one, right? Don't choose multiple check boxes, because if I choose multiple check boxes, I can click both single, married, divorced, and widowed all at the same time, which is so impossible. So make sure it's multiple choice, all right? Additional nursing degree, maybe I'm a nursing officer there, and then click next, and this is how it looks like. Everyone, can you see how it looks like, the multiple choice grid?
Yes.
Okay, you can see, right? So they can only choose one. If you put multiple choice box grid, multiple box grid, they can choose both strongly agree, disagree. They can choose 4. Okay, remember, multiple choice, not multiple check box grid. Okay? A multiple check box grid will look like a box, and you can all select all agree, disagree, strongly disagree, and strongly agree at the same time. So now they don't have other choice but to choose all these strongly agree and disagree. Okay, only one option. This is what you call a multiple choice grid. Okay, so this is what I'm talking about. You don't select. Do you see the screen?
Yes.
What am I encircling? What am I
Check
encircling?
boxes and
Check boxes.
check box grid.
Okay, do not select this, because this means they can have more than one option.
The check boxes.
Yes, they can have more than one option. It will look like a
Okay.
box, and they can both select agree, disagree, and strongly disagree at the same time, at the same question. And that is
Okay.
wrong. Do you understand me?
So you are saying we shouldn't choose the check boxes and then the check box grid.
That's right. That's why it has an X here. Never choose this checkbox grid and check boxes. Okay?
Yes, doctor.
That's clear?
Yes, sir.
Very good. So on quantitative study, you can only choose multiple choice or multiple choice grid. That's a quantitative study. Okay. Remember, you go to docs.google.com/form after you sign in from your Google. So you better sign in from your Google first. You have to have a Google account before you can make a Google survey form. And as you can see, this is the survey that you have selected, that you have done, that we have done. This is the recent form, the most recent one. This is the Google we have done. And you have to title this and click the title one. So you know, you don't get confused because you have a title here. So you click this triple dot on this right lower corner of this box, so you can rename it or just remove it. Okay, so I'm gonna remove this, or maybe later I will remove it myself, and then we will continue on with the next lecture. Did you learn something?
Yes.
Yes, sir. Yes, sir.
Okay, good. And you will do a survey form, a Google survey form, right?
Yes, sir.
Okay, so why do you need a Google survey form? Why is it necessary for you to do a Google survey form? Because here on the Google survey form, you can already get your Excel here. You will find your responses. This is your responses. Can you see the responses arrow? I'm pointing on the responses. Can you see the arrow there?
Yes.
Yeah, there's no response. Okay, there's 0. This is the Microsoft Excel, and you can download a Microsoft Excel, and this Microsoft Excel can be transferred to your SPSS. So why Google survey form? Because it has a Microsoft Excel. It will make a Microsoft Excel, and that Microsoft Excel can be transferred to your SPSS. Do you understand me?
Okay.
Okay, that is why you have to do a Google survey form. Okay?
All right.